So today we are going to graph quadratic functions a couple different ways. One by hand, okay, to start with. All right. And then we're going to utilize our technology to do it also. So we're going to take these and we're going to learn how to graph them, specifically how I can put them on graph paper. We've done the axis of symmetry, the vertex. We looked at just now the y-intercept, which is the value of c in the quadratic equation, the number by itself. And we're going to use those things to draw graphs. All right, so here we go. Here's the things you need to graph a quadratic function. The axis of symmetry, vertex, y-intercept, and then the point on the opposite side of the axis of symmetry from the y-intercept. All right, so go ahead and write this down. Things you need to graph a quadratic function. And then we're going to graph this one without our calculator or Desmos. Okay, so first of all, we're going to find the axis of symmetry. So our first step, step one, we want to find out our value of x for the vertex, which is the axis of symmetry. So x equals negative b over 2a. And if you remember yesterday when we were talking about this, one of the things I said you should do first of all is label them. Okay? Identify what a, b, and c are equal to. So a, the coefficient of x squared is 3. B, the coefficient of x is negative 6. And c is the constant, the number by itself, 1. The y-intercept. So to find that x value, or the axis of symmetry, we do negative b over 2a. So we have our negative sign. B is negative 6. And 2 times 3. Because a is 3. Really important that you identify them, a, b, and c, first of all, to help you out. So the opposite of negative 6 is positive 6. And 2 times 3 is 6. So we get x equals 1. There's my axis of symmetry. So that tells me then that when I graph this, I'm going to have, the graph is going to be mirror images on both sides of that line. You don't have to draw this line on paper. Actually, I wouldn't. Okay? I just did it there just to remind you. Okay? Now, so there's the x value. How do I find the y value for the vertex then? Josh? All right, we're going to put 1 in for x. So y equals 3 times 1 squared minus 6 times 1 plus 1. Now, first hour when we were working on these and they had a negative number, we had some struggles there. So you have to make sure that you do everything right. Now, I can type that in my calculator just like that if you need to. Okay? Right in your home screen, 3 parentheses 1 squared minus 6 times 1 plus 1, if you have to. Hopefully this you can do without a calculator. All right? Many of you can. Some of you might not be able to. That's okay. Use your calculator if you have to, until I take it away. So we get 3 minus 6 plus 1 equals negative 2. So the vertex is the point 1, negative 2. My x value is 1, my y value is negative 2. So I'm going to plot that point, 1, -2 on my graph. So set up your coordinate plane. All right. And then the third thing, it says to identify the y-intercept. We know that's C, so that's just going to be 1. Some people if you prefer to think of it as a point, then put the point 0, 1. Okay? And that's okay if you do. So we graph the y-intercept. After we have graphed the vertex, put a dot on the y-axis at +1. Now, in your book, they're going to tell you that you need 5 points to graph. Okay? I don't agree with that. Okay? You need 3. Okay? To give me a good-looking graph, all you need is 3 points. You need the vertex, the y-intercept, and you need that point on the opposite side of the axis of symmetry from it. So if I put that back in here, my axis of symmetry, here's this vertical line. If the y-intercept is on the left side of the axis of symmetry, then the other point I need is going to be the same spot but on the right-hand side of it. So since this point here for the y-intercept is 1 to the left of there, then the other point I need is going to be 1 to the right. So the point 2, 1. And there's my 3 points that I need. So now you can draw your line. Just don't forget to put your arrows. So your graph should go through those. Now, if you want to put more points, you can. All I would need to do is pick another point outside of them. Pick an x value. Like if I pick -1, I can put -1 in, find the y value, plot that point. Well, then 3 is going to have the same y value because they're the same distance from the axis of symmetry. So we find the vertex, or the axis of symmetry. Use that to find the vertex. Graph the vertex, y-intercept, and then that other point. Right? So using Desmos, the ones where everything's not on the same side, all right, it's not in the form y equals, we can just graph it with Desmos. We graph it, and if we click on the vertex, it'll tell us what the vertex is, and it'll also give us the point for the y-intercept. The harder part for that then, the only tough part then is finding that other point, which you should be able to do that. So the last thing then, all right, let's look at a story problem where, and let's do this one here. Okay, it says the height in feet of a basketball can be modeled by this function, -16x squared plus 32x, where x is the time in seconds after the basketball is thrown. It says find the basketball's maximum height and the time it takes to reach this height. Then find how long the basketball is in the air. Okay? This is a calculator problem. Okay? Plain and simple. All right? So first, let's use Desmos. You got it open. Put -16x squared plus 32x in Desmos. And they're asking us for 3 things. The maximum height, time to get there, and how long the basketball is in the air. So we're finding three answers. Maximum height, time to get there, and how long is it in the air. Now, this is not a realistic basketball problem, okay? Because where's the basketball starting from? Anybody know? The ground. Okay? The basketball is starting from the ground. If it started from where Brooke shot it, then it would have like plus 5.5, plus 6 here. Okay? Because, I don't know, I've never seen anybody shoot a basketball from the ground. Okay? Sometimes the questions aren't completely realistic, but that's okay. We can work with that though. Okay? So, negative 16x squared plus 32x. Right? So here it is. All right. So I'm trying to find the maximum height. So what am I looking for? What do we call that spot? Where the graph changes from going up to coming back down. What do we call that? The vertex. Okay? We need the vertex. So I can do a couple things. So I can either scroll out or I can just pull it down. And then click on the vertex. So I have the point 116. What does the 1 stand for? It stands for x. And what does x refer to in this case? Nope. It is. It would be the axis of symmetry. But what does x stand for in the problem? Okay, we have a story problem that has x in it, and x is time in seconds after it's thrown or shot, okay, or kicked, all right, or whatever may happen. That's time. So this vertex then tells me the time till the ball got there, and the 16 tells me the height of the ball. So my first response is going to be that has a maximum height of 16 feet after 1 second. And you are going to write a sentence anytime it's a word problem. Okay? So the height of the ball will be 16 feet when it's 1 second into the air. Now, the nice thing about the problems you're working with right now is that if it starts on the ground, it goes up and it comes down. So if it takes 1 second to go up to the max, it's going to take 1 more second for it to come back down. So how long is it in the air? So then I can go back down here, and I'm looking for that thing called a 0. All right? Oops. Started at 0 seconds on the ground, landed back on the ground in 2 seconds. So has a maximum height of 16 feet after 1 second, and the ball hits the ground then after 2 seconds because the height, the y values, are 0 again. Okay? So x value is time, y value is height for these ones you're working on. Now we could change this a little bit, and with Desmos it would work real well if we got realistic and said that Brooke shot the ball at 5 feet 6 inches off the ground, or 5 feet for her is probably more like 5'9" or 6 foot when she shoots it, okay? Because she probably shoots it up here, not down here like Pistol Pete, okay? Or Brett Hordutchny when he shoots the ball from down there, right? Okay? A little more realistic when we change them height. But on the ones you're working with right now, it starts at 0, so it's going to come back down to 0. All right. Okay, so your assignment then.